Hi and good day, I'm Rahifa binti Ranum. In this video, I will explain the Fourier series of full range. At the end of this session, you should be able to define the Fourier series of full range and identify Fourier series for odd and even function. What is Fourier series? It is a series that represents a real periodic function as an expansion in a series of sine and cosine. So these are the common examples of periodic functions which can be seen in many engineering applications. The examples are square wave function, sawtooth wave function, triangle wave function, and semicircle function. So the Fourier series method can be used to determine the unknown coefficients arise in solving partial differential equations. So where can we see this application of Fourier series? It can be seen in electrical engineering problem, vibration analysis, in the optics, signal processing, and image processing. For example, this is a square wave function. So how can a sine function make a square wave function? So the target is the square wave function, the blue line. We're going to start with the sine x, the red line. When we plot the sine x, this is how it looks like. If you add more function, more sine wave into the equation, sine x plus 1 over 3 sine 3x, and we plot the summation of the sine waves, the plot looks like the black line. If we add more sine wave function, sine x plus 1 over 3 sine 3x plus 1 over 5 sine 5x, and we plot the summation of the sine wave, the plot is starting to look a square wave. Then let's try to add more sine wave to get a better approximation to the square wave function. So the summation of the sine wave is called Fourier series. In this slide, I'm going to show you the formula of Fourier series. Let a function ft, a periodic function, defined in the interval t from minus L to L with period t equals 2L. If the function ft is either continuous or has finite discontinuities at some points in the interval, hence the Fourier series for the function ft is given by the function ft equal to a0 over 2 plus the summation of an cos n pi t over L plus bn sine n pi t over L from n equals to 1 to infinity. The a0, an, and bn are called the Fourier coefficients, and they are defined by a0 equal to 1 over L, the integration of ft with respect to t from negative L to L, while for the coefficient an equal to 1 over L, the integration of ft times cos n pi t over L with respect to t, where t from minus L to L. Last but not least, the formula of the Fourier coefficient of Bn is 1 over L, the integration of ft sine n pi t over L with respect to t, where t from minus L to L. Let's take a look at this table. Recall that functions can be divided into three types of functions. The types are odd function, even function, and neither even nor odd functions. We also note that sine function is an odd function, while cosine function is an even function. Therefore, by identifying the types of functions, we can select appropriate formula to obtain the Fourier series. If the function is an odd function, then use formula Fourier sine series. If the function is an even function, we use the Fourier cosine series formula. On the other hand, if the Fourier series is neither even nor odd function, then we use Fourier series formulas which have been shown in the previous slide. Alternatively, the odd and even function can also be solved using Fourier series formula for the interval from negative L to L. The slide shows the formula for Fourier sine series, also known as Fourier odd series. If the function is an odd function, the Fourier series is given as ft equal to the summation of bn sine n pi t over L, where n from 1 to infinity. For the interval from negative L to L, where the Fourier coefficients of a0 and an equal to 0. The formula of Bn is 2 over L, the integration of ft sine n pi t over L with respect to t, where t from 0 to L. So instead of solve the coefficient of Bn in the interval from negative L to L, we solve it in the half range 0 to L and multiplied by 2. The formula for Fourier cosine series, also known as Fourier even series. If the function is an even function, then the Fourier series is given as ft equal to a0 over 2 plus the summation of an cos n pi t over L, where n from 1 to infinity for interval from negative L to L, where the Fourier coefficient of Bn equal to 0. The formulas of the Fourier coefficient of a0 is 2 over L, the integration of ft with respect to t from 0 to L, and the formula of Fourier coefficient an is equal to 2 over L, the integration of ft cos n pi t over L with respect to t from 0 to L. Again, I repeat that instead we solve the coefficient in the interval of negative L to L, we solve the coefficients in the half range from 0 to L and multiplied by 2. Note that if the function is neither an odd or an even function, then we use Fourier series formulas. Here are the working steps to determine the Fourier series of a periodic function. Step 1. Determine the parameter L from the given periodic function. Step 2. Determine whether the function is an odd function or an even function or neither function. Step 3. Identify which Fourier series formula that we are going to use to determine the Fourier series. If the function is neither function, then we use Fourier series. If the function is an odd function, then we're going to use the Fourier sine series. If the function is an even function, then use Fourier cosine series. Step 4. Calculate the Fourier coefficients a0, an, and bn. And the last step is substitute the Fourier coefficients into the formula of Fourier series. Some helpful identities for calculating the Fourier coefficients. We know that the sine 0 is equal to 0 and cos 0 is equal to 1. Since the sine function is an odd function, therefore sine minus t equal to minus sine t. Cosine function is an even function, therefore cos minus t is equal to cos t. Sin n pi is equal to 0, while cos n pi equal to minus 1 to the power of n, where n is integers. And sin 2n pi always equal to 0. Lastly, the cos 2n pi is always equal to 1 for n integers. So that's it for today's lesson. I'll see you in the next video. Thank you.